Hi, in this video we're going to learn about rational exponents. As a review, let's have your definition of your exponents first. Remember the term A here is your base, and of course your M is your exponent. Now, remember, if you have an exponent, it means the exponent is the number or determines how many times the base is multiplied to itself. It's not multiplying the number and the exponent. Okay? When you have a rational exponent, it means your exponent is a fraction. M is actually your power. N becomes the root. And of course, A is the base. And this expression can be written in a radical form. In a radical form, your n is the root, which is the number that appears on the upper left of your radical. So if this is 2, which is called square root, and if this is 3, it's cube root, 4 is fourth root, and so on and so forth. There is no such thing as one root. The power can be written outside. This is the general form we usually used, so we could simplify a rational expression if the base is a number or an integer. It can also be written in a different way. The power can also be written inside the radical. So therefore, if this is the given, you can write the power outside, it's the same, and then you can find the root of the base if the base is a perfect root number. Okay, here's your n root explanation. If n is a natural number greater than 1 and nth root of x is a real number, then of course we can write x is the power, has a power of 1 over n, which is actually your nth root of x. So I have an example. Let's say 10 has a power of 1/2, and we are going to raise it with 2. And remember your power rule. And another expression, square root of 10 to the power of 2, are actually both equal to 10. Why? If you have a power of a power rule, you are supposed to multiply. 1/2 of 2 is 1, and 10 raised to 1 is 10. Square root of 10 is actually just another way of writing this. Therefore, they are the same. If you have square root, you can write it this way. Raised to 1/2, 1/2 times 2 is 1, then it's equal to 10. What's with this? This is a proof that we can define, removing your 2, we could clearly show that 10 raised to 1/2 is the same as square root of 10. It is very important to note that if you have a square root, which is supposed to be 2, 2 is not written. Just like it is understood that if there is no power, it's understood that the power is 1, and that all real numbers has a denominator of 1. For root, if there's no number, it means square root. Again, there is no such thing as one root or first root. It starts with square root. Likewise, if there's 3, 1 over 3 as a power of 10, then it's actually called cube root of 10. And if you have 4, 10 raised to 1/4, it's actually fourth root. The next one is fifth root, sixth root, and the rest is rarely mentioned. Okay. Here is your table of perfect square roots and perfect cube roots. As for reference, in case you don't want to use a calculator when simplifying your expressions, given that a base is of course, a perfect square root or a perfect cube root. Now, more examples. We could say that here there's no 2. It's understood that the square root of 25 is the same as 25 raised to 1/2. That is from radical to exponential form. Square root of 25 is the radical expression. 25 raised to 1/2 is a rational exponent. Why is the square root of 25 equals 2 out of 25 raised to 1/2 power? They are just the same because 25 raised to 1/2, the other way of writing of it is the square root of 25, which was shown as a proof a while ago with the number 10. On the other hand, both of these expression is equal to 5. Okay, here is your first example, problems. Evaluate 4 raised to 1/2 in radical form and simplify. Of course, it's just a simple square root of 4, and square root of 4 is 2. Let's wrap up the level of difficulty. What if your 4 has a power of 3/2? How do you simplify? First, we need to write it in radical form. 3 is your power, 2 is your root. Root is written in front on the upper left. Since it is a square root, we don't need to write it down. 2 does not appear. Why do we have to write it this way? Because 4 is a perfect square root, which was shown in example 1, which is equal to 2. Square root of 4 is 2. And now we can actually simplify 2 cubed. What is 2 cubed? That was shown in your very second slide, which is how do you evaluate exponents, which is 2 times 2 times 2, and you have 8. We were able to simplify 4 to the power of 3/2 by following the formula of your nth root. Let's proceed. Example number 3. This time you have a negative. Watch out, negative. If there is no parenthesis, it's actually not part of the power. So, to simplify, we can clearly show that since negative should not be part unless we would know it's part of the power if there's enclosed parenthesis and that negative is inside. So to write this down, we write negative in front of the parentheses. 3 becomes the root. It's now a cube root. 4 is written outside. Why do we do this? Because 27 is a perfect cube root number. Has a perfect cube root, which is 3. 3 times 3 is 9. 9 times 3 is 27. So we write down 3. Because that's the cube root of 27, you can also refer to the colorful table of roots. Negative is not part of the power of 4, so we just multiply 3 to itself 4 times, and it's 81. So the final answer is negative 81. Remember that negative is outside of the base unless there is a parenthesis and that negative is inside, then it's part of the power. You can use calculator, and scientific calculator follows that rule. Let's have example number 4. Here you have a binomial raised to the power of 3/5 in radical form. 5 is the root, and the whole expression is enclosed with a parenthesis with a power of 3. This is a lot of work. We just wrote the expression in its radical form, and this is called fifth root. Fifth root of the cube of 4x minus 1. Now, if there is a negative, remember your negative exponent, it flips. The expression goes down as a denominator. If it is originally a denominator, it becomes a numerator. So, example, No, this is an example. This is a definition of the variables. M is the power, N is the root, A is the base. Now, here's your example problem with a negative exponent. We write it first in a radical form. Cube root. 3 is the root, written in front of the radical. 2 is a power, written outside. 27 has a perfect cube root, which is 3. No, it was written down first. So you could simplify, we could get rid of the negative sign of the 2, so it's positive now. So you have cube root of 27 is 3, and 3 squared is 9. So the final answer is 1 over 9. And that's it. At the end of the video, you were expected to learn how to write a exponential rational into radical form, and from radical to exponential expression with a rational exponent. You should familiarize yourself also with the perfect cube roots and perfect square roots. It helps when you simplify perfect cube roots and perfect square roots. And that's it. Thank you.